Welcome to my channel. In this video, we have a fine combination of both exponential and trigonometric functions giving us an equation. We are to solve 16 to power sine squared x plus 16 to power cos squared x is equal to 10. How do we go about this? We are going to, first of all, find particular solutions to this equation, and then we will now find the general solution. The particular solutions are solution points. For us to solve this equation, we need to remember or apply a trig identity, which is cos squared x plus sine squared x is equal to 1. So if we make cos squared x the subject, we'll have 1 minus sine squared x. So we'll replace 1 minus sine squared x where we see cos squared x in the original question. So it becomes 16 sine squared x plus 16 1 minus sine squared x is equal to 10. We also need to apply another law, and that is a law in indices, which is a raised to power x minus y will give us a raised to power x over a raised to power y. So we'll apply this law here. It becomes 16 to power sine squared x plus 16 over 16 sine squared x is equal to 10. Now to solve this equation, we will let 16 to power sine squared x equals to t. So there's a t here, and 16 over t is equal to 10. If we multiply through by t to clear fraction, we'll have t squared minus 10t plus 16 is equal to 0. So we'll have a quadratic equation. The factors of 16, when added together, will give us minus 10 are minus 2 and minus 8 equals to 0. So if we group them, in the first bracket, t is common, remaining t minus 2. In the second one, minus 8 is common, remaining t minus 2 equals to 0. So t minus 2 and t minus 8 becomes factors that if we equate them to 0, we'll have 2 or t is equal to 8. Now to find the value of x, we need to remember that 16 to power sine square x is equal to t. So when t is equal to 2, now 16 can be written as 2 to power 4, and we have sine squared x equals to 2 to power 1, because 2 to power 1 is 2. Now this and this will cancel out. So we now have sine squared x equals to 1 over 4. If we divide both sides by 4, is equal to, or sine x rather, is equal to plus or minus 1 over 2, or plus or minus 0.5. So x in this case will now be sine inverse of 0.5. And if we have sine inverse of 0.5, we'll have 30 as the answer. Also, sine 150 can give us 0.5. So x is 30 or 150 for sine x is equal to plus 0.5. Now, when sine x is minus 0.5, we can also find a solution point, minus 0.5. So x will now be the sine inverse of minus 0.5. So x is minus 30 or even minus 150. We'll have 4 solution points. When t rather is 8, we can also find other solution points. That is 2 to power 4 sine squared x is equal to 2 to power 3. 2 to power 3 is 8. These and these will cancel out, and so sine squared x equals to 3 over 4, and sine x will now be plus or minus root 3 over 2. Root 3 over 2 is 0.866. So sine x is plus or minus 0.8660. Now, x is equal to sine inverse of 0.866, which is 60 rather. If I also punch sine 120, I will also get 0.866. So I have x equals to 120 here. Another 2 solution points. Now, for when sine x equals to minus 0.866, we have x equals to minus 60 and minus 120. In all, we have 8 solution points. 1, 2, 3, 4, 5, 6, 7, and 8. Let us check if our solution is correct by substituting either of these values into the original equation for x. And let us assume that we are using x equals to 30. Now, 16 sine squared 30 plus 16 cos squared 30 is equal to 10. In the first case, 16 sine 30 is 0.5, and 0.5 times 0.5 is 0.25, or 1 over 4. And the same thing here, 16 cos squared 30 is cos 30 times cos 30. Cos 30 is 0.8660. If you multiply 0.8660 by 0.8660, we'll have 0.75, or 3 over 4 equals to 10 is correct. Now, we have 8 solution points. We can represent the solution points on a circle. So if we have this circle and divide it into quadrants, in the first quadrant, let's remember that sine of angles is positive. We'll have 30 here and we'll have 60 here. If I add 90 to 30, I will have 120. So I have another solution point in the second quadrant, which is 120. If I add 90 to 60, I will have a solution point in the second quadrant, which is 150. Sine of angles is positive in the first and second quadrant. But in the third quadrant, sine of angles is negative, as well as in the fourth quadrant. If I add 90 to 120, I will have a solution in the third quadrant, and that solution is 1210. Add 90 to this, I will also have another solution in the third quadrant, which is 240. Now, add 90 to this, I will have 300 in the fourth quadrant, and this is 330. All the negative values, minus 30, minus 150, minus 60, minus 120, are all equivalent of sine of angles in the third and fourth quadrants. That means that we'll have 8 solution points, and the solution points can be written as 4 pi n over 3. Now, n represents the number of cycles. In the first cycle, n is equal to 1. We'll have 4 times 3 times 2 times 1 all over 3. And so our result is 8. And we can put 8n there if we like. So now, as the number of cycles increase, so the number of solution points also increase. But we can determine the number of solution points, right, by applying this, where n is a positive integer that represents the number of cycles. Now, to generalize it, let us remember that each solution point represents a particular solution. Generally, in the first case where x is equal to 30, I was saying we can add and even subtract 90 from it and have a particular solution or a general solution. Now, if that is the case, this can be a general solution to this equation. Also, if x is equal to 60, I can add or subtract 90 from it, and I also have another general solution. All these solutions are in degrees. I can convert the solution points or the general solution in radians. That is, pi radians is equal to 180 degrees. And if that's the case, if I have x, then I need to express 30 in radians. So I'll do this. X will now be, generally, I can add and subtract 90 from it, and 90 is pi over 2. Let us remember that we have a whole number, n. We can put our n there. Also, when x is equal to 60, I can also have an expression of the solution point in radians. So it becomes 1 over 3 pi plus or minus pi over 2n, where n is a member of the sets of positive integers.